In chemistry, an amphoteric compound is a molecule or ion that can react both as an acid as well as a base. The word is derived from the Greek word amphoteroi, meaning both. Many metals form amphoteric oxides or hydroxides. Amphoterism depends on the oxidation state of the oxide. One type of amphoteric species are amphoprotic molecules, which can either donate or accept a proton. Examples include amino acids and proteins, which have amine and carboxylic acid groups, and self-ionizable compounds such as water. Ampholytes are amphoteric molecules that contain both acidic and basic groups and will exist mostly as zwitterions in a certain range of pH. The pH at which the average charge is zero is known as the molecule's isoelectric point. Ampholytes are used to establish a stable pH gradient for use in isoelectric focusing. Amphoteric oxides and hydroxides. Zinc oxide reacts with both acids and with bases. In acid, ZnO plus 2H plus zinc 2 plus H2O. In base, ZnO plus H2O plus 2O minus zinc 4 2 minus. This reactivity can be used to separate different cations, such as zinc, which dissolves in base, from manganese, which does not dissolve in base. Aluminium hydroxide is also amphoteric. As a base, Al3 plus 3 hydrogen chloride AlCl3 plus 3H2O. As an acid, Al3 plus NaOH Na, Al4. Some other amphoteric compounds include beryllium hydroxide with acid, B2 plus 2 hydrogen chloride BeCl2 plus 2H2O with base, B2 plus 2 NaOH Na2, B4. Aluminium oxide with acid, Al2O3 plus 3H2O plus 6H3O plus 2, Al6, 3 plus with base, Al2O3 plus 3H2O plus 2O minus 2, Al4 minus. Lead oxide with acid, PbO plus 2 hydrogen chloride PbCl2 plus H2O with base, PbO plus 2 NaOH plus H2O Na2, Pb4. Some other elements which form amphoteric oxides are gallium, indium, scandium, titanium, zirconium, vanadium, chromium, iron, cobalt, copper, silver, gold, germanium, tin, antimony, bismuth, and tellurium. Amphoprotic molecules. According to the Bronsted-Lowry theory of acids and bases, acids are proton donors and bases are proton acceptors. An amphoprotic molecule can either donate or accept a proton, thus acting either as an acid or a base. Water, amino acids, hydrogen carbonate ions and hydrogen sulfate ions are common examples of amphoprotic species. Since they can donate a proton, all amphoprotic substances contain a hydrogen atom. Also, since they can act like an acid or a base, they are amphoteric. Examples. A common example of an amphoprotic substance is the hydrogen carbonate ion, which can act as a base. HCO3- plus H3O plus H2CO3 plus H2O, or as an acid. HCO3- plus O- CO32- plus H2O. Thus, it can effectively accept or donate a proton. Water is the most common example, acting as a base when reacting with an acid such as hydrogen chloride, H2O plus hydrogen chloride H3O plus Cl-, and acting as an acid when reacting with a base such as ammonia, H2O plus NH3NH4 plus O-. Not all amphoteric substances are amphoprotic. Although an amphoprotic species must be amphoteric, the converse is not true. For example, the metal oxide ZnO contains no hydrogen and cannot donate a proton. Instead, it is a Lewis acid whose zinc atom accepts an electron pair from the base O-. The other metal oxides and hydroxides mentioned above also function as Lewis acids rather than Bronsted acids.